Hello everyone, welcome back to my channel. I hope everyone is doing great. Let's solve second problem of weekly context 488. Okay, merge adjacent equal elements. You are given an integer array nums. You must repeatedly apply the following merge operation until no more changes can be made. If two adjacent elements are equal, choose the leftmost such that leftmost such adjacent pair in the current array and replace them with single element equal to their sum. Okay, after merging the operation, the size of the array reduces by 1. Repeat this process until updated array has no more changes to made. Okay, return the final array after all possible merge operations. Let's take an example. Let's say this is an array. If you see, these are the two numbers which are equal. Now I have to merge these two and replace it with their sum. Now after merging it, if you see, the number before to it is actually equal to the number, so we should also merge these two and replace it with their sum. Now the number before to it is equal to the sum of the previous two numbers which we have merged. Again we have to merge these two. Okay, at any given point, you see, the sum which was formed, if it is equal to the last element, okay, the last element so far, then we should again process it. Okay, as long as the updated sum is not equal to the previous element to it, or there are no more elements to process. Okay, so this, if you see, at any given point we only require the last but one element, okay, the topmost element. Okay, so this leads us to use a data structure called stack. In the stack, at any given point we'll only access the topmost element so far we have. Okay, so what we will do is we'll just process through the nums array, and then, okay, we'll just check whether our stack is not empty, and if the stack's top is equal to the stack's top, if it is equal to my current element, then I will update my current to the sum, and then again I will check whether the stack's top is equal to my current. If yes, again I will update my current to the sum. So this process will be continued as long as my stack is not empty and my peak is not equal to current. In then, when the current will have the updated sum, okay, the final sum which we have to keep it back, so we'll just push that current element to the stack again. Okay, so by the end of this algorithm, you will see we have just applied all the process which was mentioned in the problem statement. Okay, in the end I should just return a list of long, so that is what I am doing over here. If you submit this problem, all the test cases will be passed and it will be pretty efficient solution. Okay, now let's try to analyze the time complexity and the space complexity of this problem. Okay, if you see, the time complexity is, we are basically iterating through the array, and we are basically summing up the elements if it matches and then repeating it. Okay, let's say, if let's only consider this part of it. Okay, so previously there were n elements. Now I have summed this and then replaced it with its corresponding sum, and then I've taken this. So at max we are only iterating a particular element twice. Okay, one in the forward direction and one in the backward direction. Okay, so the overall time complexity will be, in the worst case, big O of 2n, so we can say big O of n. Okay, and the space complexity is, can also go up to order of n. Okay, where all the elements are unique and there are no pairs which are actually matching, so this can also go all the way up to big O of n. So the time and space complexity of this algorithm is big O of n. Okay, if you like the explanation, hit the like button and hit the subscribe button, and also share your valuable feedback in the comment section. I will be posting the code snippet in the form of link in the description. You can also reach out to it. Thank you.